This is the answer to number 1 on the 8.2 warm-up and critical points and EVT worksheet. It says determine the absolute max and absolute min values of f on the given interval. So f of x equals the square root of 9 minus x squared, and we're on the interval from -1 to 2. Well, the first thing is I know that this is a continuous function on this interval. This is a semicircle, and it's the top part. And I know that because the domain goes from -3 to 3, and a circle does not have any jumps or asymptotes on their domain. So the first thing we have to do is find the derivative, because we have to find the critical points. And the critical points is when the derivative is 0 or undefined. So I am going to think about the square root as the 1/2 power. So f prime of x. If this is the 1/2 power, power rule tells me to bring the 1/2 down, keep the inside exactly the same, and then reduce the power by 1. So that would be now to the -1/2 power. And then chain rule, don't forget that, the derivative of the inside is -2 times x. Well, the thing is, I want to simplify this because most of the time these are going to be problems that you can do without a calculator. And so, well, 1/2 times 2 is 1, and then I have this negative. So it's going to be -1 on top. And then this -1/2 is just the square root on the bottom. So it's now the square root on the bottom of 9 minus x squared. Well, if I set this equal to 0, one of my critical points is when x equals 0. Okay? And then setting the bottom equal to 0 would also be when your derivative is undefined. So if you have a continuous function and an undefined derivative, that could be that there is a cusp. But knowing that this is a semicircle, I know that there isn't a cusp. The other thing is the vertical tangent lines on the end. The only thing is the bottom would be 0 when x is -3 or 3. And that is not in our in our interval. We're only going from -1 to 2. So we don't have to worry about -3 and +3. So after you've found the critical points, what I'm going to do is plug the critical point into the function as well as the endpoints into the original, because I'm trying to figure out which is the absolute max and which is the absolute min. Because if I have a continuous function, then there must be a point that is a maximum and a point that is a minimum. So I'm going to just go in the order. So f of -1, when I plug that into my original function, I get the square root of 8. When I plug in 0, 9 minus 0 squared is just square root of 9, which is 3. And then when I plug in 2, that's my other endpoint, 9 minus 2 squared, well, that's 4. 9 minus 4 is 5, so I get the square root of 5. Now, doing this without a calculator, you should know that the square root of 8 is less than the square root of 9, and the square root of 5 is even smaller than the square root of 8. And so without having those decimals, you should be able to figure out which is the largest and the smallest. Well, 3 is the largest, so our absolute max is at the point 0, 3, and then our absolute minimum is at the point 2, square root of 5.